So, picture this. It is 3:00 a.m.
Oh, no.
Yeah, exactly. Your pager goes off, tearing you out of a deep sleep. A critical application just crashed in your production environment.
The absolute worst way to wake up.
Right. So you drag yourself out of bed, rub your eyes, fire up your laptop, and log into the SAP BTP cockpit. And, well, the app is running perfectly.
It's humming along.
Exactly. The dashboard is just a sea of calming green. The error is completely gone, so you can just close your laptop and go back to bed.
I mean, you could, but you definitely shouldn't.
Wrong. Because the platform detected the crash and automatically restarted the application, which sounds great, but the evidence of why that application crashed just burned with the ship when the container restarted.
Yeah, it's completely gone.
When your team logs in the next morning, they will have absolutely no idea what caused that failure. So today we are going to show you how to automate the forensic capture of that data the exact millisecond an error occurred.
Right, before the evidence just vanishes into thin air.
Exactly. We are taking a deep dive into the architecture of SAP BTP DevOps. We've got this massive stack of SAP learning materials, architectural guides, and DevOps best practices right in front of us.
It's a lot of material.
It is a lot, but our sole mission today is to bypass all that generic fluff and provide you, the listener, with a really hands-on, intensely technical learning guide to actually optimize your SAP Business Technology Platform operations.
And that 3:00 a.m. scenario you just mentioned, that is exactly where we're aiming this entire discussion. We're building this for the hands-on architects, the lead developers, the DevOps engineers, who are the ones actively configuring these systems.
Ones in the trenches.
Exactly, because establishing a basic deployment pipeline, that's relatively easy. That's just step one. True DevOps in an enterprise SAP environment is this continuous, deeply integrated architectural journey.
Yeah, it's not just setting up a Git repo and calling it a day.
Not at all. We have to go fundamentally beyond just pushing code. We're talking about architecting a landscape that is centrally orchestrated, fully observable, and entirely automated.
So to ground all of this in reality, we're going to follow a recurring case study from the sources. They introduce this fictional company with a pretty memorable name, actually.
Rotating Banana.
Yes, Rotating Banana. I kind of love it. Anyway, their DevOps team is fundamentally successful in the early stages. They've embraced agile methodologies, they're building modern cloud-native extensions on SAP BTP, and they are deploying successfully.
So far, so good.
Right. But they have hit the day two operations wall hard. They are suddenly just drowning in unexpected application issues in their production environment.
Which is super common, honestly.
Yeah, and their engineers are suffering from massive alert fatigue. They're largely ignoring their pagers at this point, and they're burning an enormous chunk of their development sprints just executing manual remediation tasks.
Digging through disconnected log files, restarting stuck services manually, all that toil.
Exactly. So today, we are stepping in as their architectural rescue team.
I love that framing, because it really is the classic trap of cloud-native adoption within a legacy enterprise. A team gets the initial deployment working, the business throws a party because of the speed of delivery.
Right, look how fast we are.
Exactly. But then the reality of maintaining that speed without breaking the overarching enterprise system just hits them like a ton of bricks. We have to architect a comprehensive rescue plan for Rotating Banana today.
And we really want to focus on specific, actionable configurations that you can map directly to your own environments.
Absolutely. Actionable is the key word here.
Okay, so before we can even begin to observe an application or, build automated remediation flows to fix it, we have to deeply understand how that application physically moves through the SAP landscape. We need to dissect the architecture of delivery.
Right, the logistics of it all.
Yeah. So if we're looking at the very beginning of the lifecycle, walk us through the physical flow of a modern deployment on BTP.
Okay, let's trace a standard SAP Continuous Integration and Delivery, or CI/CD, job flow. Imagine a developer at Rotating Banana finishes a new feature for their inventory sync app.
Okay, got it.
They commit that code to their Git repository. Now, this commit automatically kicks off the CI/CD pipeline. The pipeline pulls the code, spins up a build environment, compiles the app, runs all the automated unit tests, and does static code analysis.
Pretty standard stuff so far.
Right. But here is the critical divergence from, say, a simple startup environment. In an enterprise SAP landscape, this CI/CD pipeline does not just blindly push the resulting code directly into the live production space.
Okay, point on.
Because there is a very specific, deliberate handoff mechanism required.
I wanted to dig into the mechanics of that exact handoff, because I think this is where people get tripped up. When the CI/CD pipeline finishes all its validation, what exactly is it handing over and to what?
Okay, so the pipeline packages the entire application into a multi-target application archive. You'll hear it called an MTA archive constantly.
Right, MTA.
If you are working in BTP, you have to be intimately familiar with MTAs. Think of the MTA as a highly structured, self-contained shipping crate.
Okay, a shipping crate. I like that analogy.
Yeah, because it doesn't just hold your back-end Java or Node code, it holds every single module of your application.
So the database, too?
Exactly. The HANA database schema definitions, the back-end business logic, the front-end SAP UI5 interface, and even the exact role collections and security configurations that are required.
Wow, so it really is everything in one box.
Yes, and crucially, it includes an enta.yaml manifest file. This file explicitly defined how all these disparate microservices relate to one another, how they bind to specific BTP services, and what specific resources they need.
So it's not just, a zipped folder full of code. It's a declarative blueprint of the entire application state.
Precisely. It's a blueprint. Once that MTA archive is built and successfully passes all the pipeline tests, the CI/CD service takes that archive and securely uploads it to the SAP Cloud Transport Management Service.
Ah, okay, so this is the handoff.
This is the handoff. The CI/CD pipeline effectively acts on the development node of your landscape. It builds the payload, generates a transport request, exports that MTA archive, and places it squarely into the import queue of the next logical node in your landscape.
Which would normally be, what, a QA or test environment?
Exactly, the test transport node. And concurrently, depending on how your landscape routing is configured, this transport request is also usually forwarded into the import queue of the production node as well.
But it doesn't install automatically.
No, the MTA archive just sits in those secure queues waiting for an explicit command to actually be imported.
Okay, I can literally hear the Agile purists in our audience bristling at this right now.
Oh, I'm sure they are.
Because if I am a lead developer at Rotating Banana and we are building cloud-native microservices entirely on BTP, I'm thinking, why can't I just configure my CI/CD pipeline to deploy all the way to production?
It's the obvious question.
Right. Why are we intentionally introducing the friction of a transport management system? If my pipeline is a high-speed automated assembly line, forcing it to hand off to transport management feels like forcing all my fast-moving goods to go through a slow, bureaucratic customs checkpoint.
A customs checkpoint is a great way to describe it.
Yeah.
And it seems to contradict the whole concept of continuous delivery, right?
Exactly. It feels slow.
It's a really common frustration for developers who are transitioning from purely standalone web development into enterprise architecture. But the necessity of this customs checkpoint comes down to overarching enterprise governance.
Governance, the magic word.
Always. It's governance, it's the extreme complexities of hybrid landscapes, and the absolute requirement for synchronized, auditable deployments.
Make that real for me.
Okay, if you are a startup running a single isolated app, by all means, deploy straight to production from your pipeline. Have at it.
Right, move fast and break things.
Exactly. But Rotating Banana is an enterprise. Their BTP applications are not islands. That new inventory synchronization app on BTP is likely making real-time OData calls to a massive on-premise SAP S4 Age ANA backend.
Oh, I see. Or pulling employee data from SuccessFactors.
Exactly. So a single logical business feature actually requires a backend database change on-premise and a front-end UI change in the BTP cloud.
Which means they have to go live at the same time.
Exactly. If you allow the BTP Agile team to just push to production whenever their CI/CD pipeline flashes green, they might automatically deploy a front-end application that relies on a new back-end API that hasn't actually been deployed to the on-premise production system yet.
Oh, wow, yeah. The moment that front end goes live, the system crashes and the business stops.
Total outage. SAP Cloud Transport Management acts as the great synchronizer across those boundaries. It allows a central release manager to orchestrate deployments across highly disparate environments simultaneously.
So it's about control.
Control and visibility. Furthermore, it provides an immutable, centralized audit log. In an enterprise, you must know exactly who approved a change, what tests were verified, and exactly when it was moved into production. You have to strictly adhere to idle processes and quality gates.
So the friction is intentional.
Highly intentional. It ensures the entire enterprise ecosystem doesn't collapse from a single out-of-sync deployment by one Agile team.
Okay, that makes a lot of sense. So it is essentially a decoupling of the build phase from the release phase to ensure safety.
That's a perfect way to summarize it.
So for the architects configuring this, you really have to make conscious decisions about how those transport queues behave. The sources we're looking at specify configuring manual versus scheduled automatic imports.
Yes, and this configuration must directly reflect your organization's specific governance model.
How so?
Well, for a quality assurance or test node, it's actually highly common to configure scheduled automatic imports. For instance, you might set the queue to automatically import all waiting transports every night at midnight.
Okay, so the QA team always wakes up to the latest integrated build for their daily testing.
Exactly, no waiting around. However, for the production node, you will almost certainly configure manual imports.
Because of the risk.
Right. These are tightly controlled, usually executed by a dedicated release manager, and they are explicitly tied to a predefined release window or a formal change advisory board approval process. You don't automate a production push without serious oversight.
While we are looking so closely at the architecture of transport management, the texts highlight a very specific, somewhat counterintuitive concept that architects need to utilize, and that is virtual transport nodes.
Ah, yes, virtual nodes.
Walk us through the mechanics of this. Why would we build a node that doesn't actually exist? It sounds like an oxymoron.
It does, but virtual transport nodes are actually a brilliant architectural workaround for solving a very messy reality of hybrid cloud deployments.
Okay, messy how?
Well, the physical landscape of your modern BTP environment rarely, if ever, matches the physical landscape of your legacy on-premise environment one-to-one. Let's look at rotating banana again.
All right, back to the bananas.
Their on-premise SAP landscape is robust and traditional. They have a development system, a dedicated quality assurance system, a pre-production staging system, and a live production system.
4 completely distinct physical environments.
Right, but over in their BTP global account, to optimize cloud consumption costs and reduce overhead, they might only have 2 sub-accounts provisioned, one for development and one for production.
Wait, really? Just 2?
Yeah, it's incredibly common. Why pay for a massive QA sub-account if you can test locally or rely on other methods?
Okay, so there is a fundamental structural mismatch there. The enterprise change management process is mandated to track a transport through 4 distinct phases, but the physical cloud infrastructure only has 2 destinations.
That is the exact friction point. If their overarching central change management tool tries to orchestrate a synchronized deployment, it is strictly programmed to move the transport to the QA node first.
And if that physical node doesn't exist in the BTP landscape?
The entire synchronized orchestration fails, it throws errors or behaves unpredictably, and completely halts the release.
Oh, wow. So how do you fix it?
This is exactly where you configure virtual transport nodes within SAP Cloud Transport Management. You literally go into the system and create a node, and you explicitly name it, say, BTP_QA.
Okay.
But here's the critical configuration step. You do not assign a physical target sub-account to it. You provide no transport destination, and you define no specific content type.
It is essentially a logical placeholder, like a ghost node in the routing map.
A ghost node is the perfect way to describe it. It totally streamlines the overarching transport landscape. It allows the central application lifecycle management tools to hit that node, tick their compliance boxes, and generate the necessary audit logs saying, yes, the transport has successfully passed through the QA phase.
And then it just forwards it to the next queue.
Exactly. It keeps the overarching enterprise transport logic perfectly intact and synchronized across the hybrid environments, but it entirely removes the requirement for you to actually spin up, maintain, and pay for a physical QA sub-account in BTP that your cloud-native team doesn't actually need.
That is an incredibly elegant solution to a really rigid governance problem.
It's a massive configuration lifesaver for hybrid architects.
Okay, so we have established how the code physically moves. We understand the MTA structure, and we see how transport management handles that critical handoff from the agile developers to the enterprise delivery managers, using those virtual ghost nodes to smooth over any landscape mismatches.
Right, the logistics are sorted.
But all of this logistics infrastructure requires a central brain to monitor and direct it. I mean, once we have our delivery logistics set up, we really need a central watchtower.
Exactly, because BTP, as we've noted, doesn't exist in a vacuum. You cannot manage an enterprise landscape by logging into 50 different individual BTP sub-accounts or checking a dozen separate CI/CD dashboards every morning.
That sounds like a nightmare.
It is. We need a central nervous system and a central brain.
The sources outline 3 distinct application lifecycle management, or ALM, platforms provided by SAP. So let's break down the strategic positioning of these 3 platforms so teams know exactly which one they should be targeting for their architecture.
Sure.
The big 3 are SAP Cloud ALM, SAP Focused Run, and SAP Solution ALM.
Yeah, SAP Cloud ALM is the strategic focal point right now. It is the go-to cloud-native solution designed entirely from the ground up for cloud-centric and hybrid customers.
So if I'm starting fresh today,
If you are a new SAP customer today, or you are embarking on a major cloud transformation, this is your starting point and your end goal. It provides standardized, out-of-the-box ALM processes for both the implementation phase and ongoing operation.
and it's SAWS, right?
Exactly. Because it's hosted in the cloud, it receives continuous updates without any upgrade effort on your part. No weekend downtime to patch your ALM tool. And it integrates seamlessly and natively with the vast majority of BTP services. It's really designed for agility and rapid time to value.
Okay, then we have SAP Focused Run, and the name just sounds intense. Who is the target audience for this one?
The name is definitely appropriate.
Yeah.
SAP Focused Run is a highly specialized, incredibly robust on-premise solution.
So not cloud.
Not cloud. You really only look at architecting with Focused Run if you are a massive managed service provider or a global enterprise with extreme high-volume system and application monitoring needs.
Like what kind of volume?
We are talking about environments like major telecommunications companies, where the sheer volume of daily telemetry, trace data, and system metrics would completely overwhelm standard ALM tools.
Ah, I see.
It is an incredibly powerful engine, but it is a heavyweight, strictly on-premise installation that requires significant expertise to maintain. It's not for everyone.
Got it. And finally, we have to address the elephant in the room for the vast majority of established SAP customers out there. And that's SAP Solution Manager, commonly known across the industry as Solman.
Yes, good old Solman. Solution Manager is the historical backbone of SAP operations. It has managed highly customized, heavily on-premise, and really complex legacy hybrid environments for well over a decade.
Which is exactly where our case study company is at.
Right. If we return to Rotating Banana, they are currently deeply entrenched in SAP Solution Manager. They've spent years building custom change management workflows, specific monitoring alerts, and deeply integrated IT service management processes right within Solman.
They can't just abandon that.
No, but they are not blind either. They see the strategic shift in the industry. They know they need to prepare for a stepwise cloud transformation, and that means their ultimate destination has to be SAP Cloud ALM.
Let's explore that transition because this has to be a massive pain point for any established enterprise. If Rotating Banana is currently routing all of their business-critical events and orchestrating their entire release cycle through Solution Manager,
Which they are.
how do they manage this hybrid transition phase? I mean, you can't just flip a switch on a Friday night and move a global enterprise from Solman to Cloud ALM.
Oh, absolutely not. That would be disastrous.
So how do you manage having one foot in the legacy world and one foot in the cloud without dropping the ball on production monitoring?
You are absolutely right. It is never a flip-the-switch scenario. It requires highly deliberate, phased architecture. The beauty of the SAP operations architecture is that it is explicitly designed to support parallel platforms. It can handle different use cases during these multi-year transitions.
Okay, so running both side by side.
Yes. For Rotating Banana, the strategy is coexistence. They will continue to utilize the SAP Alert Notification Service, which is a critical component we will dive into deeply in a moment, to securely forward critical operational events from their new BTP applications back into their existing on-premise SAP Solution Manager.
So they basically maintain their legacy dashboards for the time being.
Exactly. This maintains their current established operational transparency. The operations team working the night shift doesn't suddenly have to learn a completely new system overnight. You don't break what is currently working.
That makes sense. Keep the lights on.
Right. But simultaneously, the architecture team starts routing specific, newly developed cloud-native scenarios directly into SAP Cloud ALM. You run the 2 ALM platforms in parallel.
And just slowly shift the weight.
Exactly. As the DevOps team gets comfortable with Cloud ALM and as legacy on-premise applications are modernized or retired, you slowly migrate workflows, alerting rules, and deployment orchestrations one by one from Solman to Cloud ALM. It is a controlled, iterative migration of that central brain.
Let's talk about the specific mechanics of wiring that central brain up to our logistics network. The goal is to integrate SAP Cloud Transport Management directly into SAP Cloud ALM, allowing ALM to control the change and deployment management capabilities.
Which is crucial.
But the architectural guides include a very specific bolded configuration warning here that I think is crucial to highlight for everyone listening.
This is one of those architectural details that can literally save a team months of headaches if you implement it correctly on day one.
Lay it on us.
When you are configuring this integration, SAP explicitly recommends that you provision and utilize one or more standalone instances of the transport management service running in your own specific BTP global account.
Standalone instances.
Yes. You should absolutely not simply use the default transport management instance that just happens to be running on the SAP Cloud ALM global account.
Okay, let's unpack this. Because honestly, why wouldn't I just use the instance that is already bundled and running with Cloud ALM? From a pure simplicity standpoint, it sounds so much easier to use what is already there rather than spinning up a whole new standalone instance and figuring out the authentication routing.
I know, it seems way easier initially. But it paints you into a massive architectural corner. There are two very specific technical reasons for this mandate.
Okay, what's the first?
First, utilizing a standalone instance deployed in your own global account allows you to seamlessly handle the transport of content originating from SAP Analytics Cloud.
Oh, really?
Yeah. The default instance running on the ALM provider account is technically restricted. It fundamentally cannot process SAP Analytics Cloud content. If you use the bundled one, the moment your data team tries to transport a new analytics dashboard or machine learning model, they will hit an inexplicable brick wall.
So it's effectively future-proofing against analytics transports. You might not need it today, but you will eventually.
Exactly. Don't lock yourself out.
What is the second reason?
The second reason is pure architectural scalability. The standalone architecture allows you to connect multiple different transport management instances, perhaps originating from various sub-accounts or different geographical regions or completely different business units into a single centralized SAP Cloud ALM instance.
Oh, I see. A many-to-one setup.
Exactly. It gives you a highly scalable, flexible, many-to-one architecture. You can have decentralized development teams managing their own local transport logistics, all while reporting up into a single, unified command and control center in Cloud ALM.
That makes perfect sense. So provision your own standalone transport management instance in your global account and point it centrally to ALM.
Write that one down, folks.
Seriously. So we have our logistics pipeline running smoothly, and we have our central brain, Cloud ALM, positioned as the watchtower. But, I mean, a central command center is completely useless if it is blind. It needs a feed of what is actually happening on the ground.
It needs eyes and ears.
We have to build the nervous system.
Precisely. If Cloud ALM is the brain, we need to feed it high-fidelity telemetry from every application, database, and service running in the BTP environment. We need observability.
The sources outline a strict differentiation between three core observability pillars in the SAP ecosystem. And it is incredibly important that architects understand the exact boundary lines and responsibilities of these three tools.
It's vital. If you blur these lines, you end up duplicating effort, paying for redundant cloud storage, or worse, looking in the wrong dashboard during a critical outage.
Which goes back to our 3.00 AM scenario.
Exactly.
So let's break down this triad. If we use the analogy of a physical security system for a massive building, how do these three pillars fit? Let's start with pillar one, SAP Cloud ALM.
In that security system analogy, SAP Cloud ALM is the central security desk monitoring the entire building complex.
The big bank of monitors.
Right. It is your high-level macro monitoring platform. It is explicitly designed for early detection by central support teams. When an operator logs in there, they are not looking at individual lines of code.
What are they looking for?
They want a high-level dashboard showing the aggregate health of business services. Like, is the web store processing orders right now? Is the back-end ERP system responding within acceptable latencies? It aggregates health metrics, performance indicators, and business process flows. It is all about broad visibility, trend analysis, and early warnings across the entire enterprise landscape.
Okay, so Cloud ALM is the macro view, the big picture. Pillar two is SAP Cloud Logging. Where does this fit into our security analogy?
If ALM is the central security desk, SAP Cloud Logging is the 24/7 CCTV system with deep zoom capabilities.
Oh, I like that, the micro view.
This is the micro in-depth view, and it is the primary tool for the hands-on DevOps engineers. When the Cloud ALM dashboard flashes red indicating a service degradation, the engineers do not stay in ALM. They dive directly into SAP Cloud Logging for the root cause analysis.
Because it has all the details.
Everything. Cloud logging handles the heavy lifting of raw, unstructured data. It ingests massive volumes of application console logs, granular performance metrics, distributed open telemetry traces, and security audit logs.
So it's where the actual forensics happen.
Yes, it provides the advanced querying, the Kibana dashboards, and the log correlation necessary to figure out exactly which line of Java code threw a null pointer exception at 2:12 a.m.
So ALM tells you something is broken, and cloud logging tells you exactly why it's broken.
It's precise.
That leaves pillar 3.
Yeah.
The SAP Alert Notification Service for SAP BTP. We'll just call it ANS to keep things brief. Where does ANS sit?
ANS is the crucial connecting tissue. In our security analogy, ANS is the array of motion sensors scattered throughout the building.
Motion sensors. Okay, how so?
ANS does not store massive historical log files like cloud logging. And it does not provide central aggregate dashboards like Cloud ALM. Its sole, highly optimized job is discrete event capture and rapid propagation.
It's just a messenger.
Exactly. It sits on the BTP platform, silently listening. When the underlying Cloud Foundry runtime detects an anomaly, for example, it detects that an application container just crashed due to an out-of-memory error. ANS instantly captures that specific, discrete event payload.
And then what?
It then fires that event off to whoever needs to know based on the routing rules you configured. It could send an email to the on-call team, it could trigger a webhook to a third-party IT service management tool, or, most importantly for us, forward the event payload directly up to the central desk at Cloud ALM.
This triad ALM, cloud logging, and ANS forms an incredibly powerful observability stack. But configuring them to work together seamlessly has to require specific techniques. You can't just plug them in and walk away.
No, you have to wire them together intelligently.
One of the most impactful configurations mentioned in the sources is implementing context-sensitive navigation. Walk us through the mechanics of this, because honestly, this sounds like a massive quality of life improvement for the DevOps team.
Oh, it's arguably one of the most important configurations for reducing mean time to resolution. Without it, the troubleshooting process is incredibly disjointed.
Paint me a picture. What does it look like without it?
Okay, an operator sees an alert in Cloud ALM. They look at the timestamp. They then open a new browser tab, log into SAP Cloud Logging, and manually start typing in search queries trying to match the timestamp and the application name, just hoping to find the exact log lines surrounding the error.
Playing detective across multiple tabs while the system is down.
Exactly. It's a manual, error-prone hunt. And while you're hunting, the business is losing money.
So how does context-sensitive navigation fix that?
You architect the integration so that when an exception log message triggers an alert on the central Cloud ALM dashboard, the support engineer is presented with a clickable link directly embedded right there in that alert.
Okay, but doesn't that just take them to the cloud logging homepage?
No, that's the magic. That link does not just open the generic homepage of SAP Cloud Logging. The URL is dynamically constructed to pass the exact operational context.
Oh, nice.
It passes the specific time window of the failure, the unique application IDs, and ideally, the distributed trace IDs directly into the cloud logging search parameters.
So they don't have to search for anything.
Right. When the engineer clicks the link, they bypass the manual search entirely and land exactly on the detailed, granular log messages immediately surrounding that specific error. It preserves the exact context of the failure, turning a 10-minute manual search into a single click.
That is fantastic. You are directly passing the variables from the macro view straight to the micro view.
It saves so much time.
The sources also detail the necessity of connecting third-party event providers into this observability stack, specifically routing them into Cloud ALM. I assume this is because nobody just uses one vendor anymore.
Yeah, modern BTP applications rarely rely solely on SAP infrastructure. Rotating Banana's new BTP app might be utilizing highly specialized AWS S3 buckets for object storage.
Or Azure for Active Directory.
Yes, exactly. Furthermore, they might have existing investments in third-party monitoring giants like Dynatrace or Grafana for specific infrastructure components. You absolutely do not want your central operations team forced to monitor 5 different screens to understand the health of a single business process.
Swivel share monitoring.
It's the worst. You utilize the open REST APIs provided by the Alert Notification Service in Cloud ALM to ingest those third-party telemetry events. You map the payloads and forward them into Cloud ALM's health monitoring, creating a single unified pane of glass. If the AWS S3 bucket goes offline, it shows up as a critical dependency failure right there on the SAP Cloud ALM dashboard.
Okay, I understand the strategic value of the unified pane of glass. It sounds great in theory. but I have to inject a massive reality check here.
Oh.
I'm thinking about the team at Rotating Banana. If ANS is sitting out there acting as our motion sensor array, catching every single event from BTP, every minor infrastructure blip from the hyperscalers, and every warning threshold from Dynatrace, and then forwarding all of that to Cloud ALM or blowing up the team's email, aren't we just going to drown them in noise?
That is a very valid concern.
I mean, this is the textbook definition of alert fatigue. If the pager goes off 50 times a day for minor warnings, the team will simply create an email rule that sends all alerts straight to the trash. They will start entirely ignoring that beautiful unified pane of glass.
Your concern is the single most common failure mode of any observability implementation. Alert fatigue fundamentally destroys operational culture. If everything is an alert, nothing is an alert.
Right. So how do we stop it?
This is why understanding the deep configuration capabilities of the alert notification service is paramount. ANS is not a dumb pipe that just forwards everything it hears. It is a highly configurable, granular filtering engine. Your crucial task as an architect is to design and implement strict conditions and logical filters within ANS.
What does that filtering logic actually look like in practice? Are we writing code here?
You build routing rules based on the JSON payload of the incoming events. You don't send every event to the pager. You might configure a rule that says, if the event severity is warning and the component is the inventory sync service, do not send an email. Instead, just log it silently to cloud logging for historical analysis.
So it's tracked, but no one is bothered at 3 a.m.
Exactly. But you create another rule that says, if the event severity is fatal or critical and the environment tag is production, immediately trigger the high-priority webhook to the PagerDuty system and forward the payload to Cloud ALM. You actively filter out the informational noise at the edge, ensuring that only truly actionable critical events ever reach human eyes.
And beyond just, muting the messenger, how do you use this telemetry data to proactively fix the system so these alerts stop happening in the first place?
That is the transition from just monitoring to actually engineering. You continuously review the aggregated metrics and trend data coming into cloud logging and ALM. If you see an application constantly bumping up against its memory limits and throwing minor memory high warning events every afternoon, you don't just filter those warnings out of your inbox.
You actually fix the limit.
Yes. You use that concrete data to justify adjusting the auto-scaling limits for that specific application in BTP. You review your SAP service plans. Are you on the right compute tier for the throughput you are actually experiencing? Improper or excessive usage of underlying resources is a primary cause of platform health issues.
So you fix the root cause before it breaks.
You must monitor the resource consumption trends just as closely as you monitor the explicit crash errors. You use the observability data to optimize the environment fundamentally, silencing the alerts at their source.
Okay, so let's summarize where we are. We have built a robust delivery logistics pipeline. We have established our central command center with Cloud ALM, and we have wired up a highly filtered, context-aware nervous system so we can see everything clearly without being blinded by noise.
We have a very solid foundation now.
Which sets the stage perfectly for the absolute core of our discussion today. This is where we move from just watching things break on a dashboard to automatically fixing them. We are going to walk through a detailed hands-on lab, triggering automated remediation actions.
This is where DevOps truly earns its name. This is the holy grail. Knowing something is broken is only half the battle.
Right.
If a human engineer has to physically log into a system at 3:00 a.m., open a command line interface, and manually type in a command to restart a service or pull a log file, your operational process is still fundamentally immature.
Ouch, but true.
The true goal of cloud operations is automated remediation resolving the issue, or at the very least, gathering all the necessary diagnostic evidence entirely without human intervention.
To achieve this, we are introducing a new, really powerful tool into our architectural stack, and that is SAP Automation Pilot.
SAP Automation Pilot is an incredible service. Its entire purpose is to simplify, codify, and automate complex manual technical operations on SAP BTP.
Like a runbook.
Think of it exactly as a serverless execution engine for your runbooks. And crucially for our architecture today, it integrates directly and natively with our central brain, SAP Cloud ALM.
We are going to architect a very specific, highly valuable automated flow to address the scenario we opened the show with, a Cloud Foundry application crash. We are going to walk you through an exact 5-step configuration guide. I want you to imagine you have the SAP BTP cockpit open right in front of you.
Let's do it.
Step 1, switch activation. What are we doing here?
First, We need to ensure the correct critical signals are flowing into our command center. You integrate the SAP Alert Notification Service, ANS, with SAP Cloud ALM. Within the Cloud ALM health monitoring setup, you navigate to the specific event configuration and explicitly activate the switch that listens for the incoming event titled SAP Application Crash.
So we are just turning the listener on.
You are explicitly telling the central brain to watch out for this specific critical failure payload.
Got it. Step 2, ALM integration.
Now we have to connect the muscle to the brain. You navigate to the SAP Cloud ALM Operations Configuration menu and establish the integration with the SAP Automation Pilot Service.
Which involves what exactly?
This involves a secure OAuth 2.0 handshake. You are essentially providing Cloud ALM with the necessary credentials, service keys, and permissions to remotely trigger execution scripts that reside over in Automation Pilot.
Okay, muscle connected. Step 3, event collection.
We go back down to our motion sensor, the Alert Notification Service. We must configure ANS to specifically listen for and collect application audit events generated by the underlying Cloud Foundry runtime.
Not the app itself, but the runtime.
Exactly. When Cloud Foundry detects that the isolated container running your application has died, perhaps it exceeded its memory quota, the runtime itself generates a specific audit event. ANS needs an explicit subscription rule configured to catch that specific CF runtime audit payload so it can forward it up the chain.
Now, step 4, which is definitely the most mechanically intensive step, command design. This is where we actually build the logic of the automation flow.
Right. You log into the SAP Automation Pilot interface. You are going to build what is called an automation flow by visually chaining together discrete commands.
Do I have to write all these scripts from scratch?
No. Thankfully, SAP provides extensive pre-built catalogs of common commands, so you don't have to write raw scripts for basic things. First, you drag in a command called getCF_AppState.
Okay, getCF_state, what does it do?
When this flow is triggered, this command immediately authenticates against the Cloud Foundry API and queries the exact real-time state of the crashed application. Next, you chain a second command called getCF_AppEvents.
To get the history.
Yes, and you configure its input parameters to capture the most recent 20 lifecycle events for that specific app ID. You are mapping the output of the first command directly into the input of the second.
So the script is rapidly grabbing the platform state and the last 20 platform events. But that doesn't give us the actual application errors, does it? We need the console logs, we need the stack trace from right before the container died.
Correct. For that, you model a custom command within Automation Pilot that interfaces with the SAP Cloud Logging API. You design this command to fetch exactly the last 100 lines of console output from that specific application's log stream, querying based on the exact timestamp of the crash.
Awesome. So now our in-memory script holds the state, the 20 events, and the 100 log lines.
Which is pure gold for forensics.
But it's just sitting in memory. We need to put this forensic evidence somewhere useful for the engineers.
Right. Finally, you drag in a command from the provided Jira catalog. You configure the JSON mapping within this command to take all that fetch data, automatically authenticate against your corporate Jira REST API, generate a brand new bug ticket, populate the ticket description with all that structured forensic evidence, and automatically assign it to the currently on-call DevOps team member based on their ID.
That is incredibly slick. Which brings us to step 5, the final wire-up, the health monitoring trigger.
Go back up to SAP Cloud ALM. You navigate to the routing rules for the app crash event that we activated back in step 1. You set up a dual action rule.
Dual action?
Yeah. When Cloud ALM receives this specific app crash payload from ANS, it must perform 2 actions simultaneously. Action A, send a generic, high-priority email alert to the DevOps team distribution list so they are generally aware an incident occurred.
And action B?
Action B, automatically trigger the specific automation pilot flow we just built in step 4, passing the application ID from the alert payload directly into the automation pilot script as the starting parameter.
Okay, I have a major piece of pushback on this entire architecture.
Let's hear it.
If I am a lead developer and I understand the fundamental architecture of the Cloud Foundry runtime, I know that it is designed to be highly resilient.
It is.
If a Cloud Foundry app crashes, say it hits an out-of-memory exception, The platform detects that failure and automatically spins up a brand new container instance and restarts the application within seconds.
True.
It is a built-in fundamental self-healing feature of the platform. So if the platform is already automatically restarting the app and restoring service to the users, why on earth are we spending hours architecting this complex 5-step automation pilot flow just to create a Jira ticket? The app is already back online.
That right there is the absolute critical insight of modern cloud operations. And it is exactly why this specific architecture is so vital.
Explain it to me because it feels redundant.
You are absolutely correct that Cloud Foundry will restart the application almost instantly. From an end-user perspective, there might just be a momentary processing blip. But from an engineering and root cause analysis perspective, that automatic restart is a massive double-edged sword.
Walk me through the mechanics of why that is dangerous.
Because modern cloud applications run in ephemeral containers.
Ephemeral meaning temporary.
Right. Temporary and stateless. When the application crashes, that specific isolated container dies, and a brand new, clean container is created from the base image. When the old container dies, it takes everything with it.
Oh, I see.
The highly localized state data, the immediate console logs stored in the volatile memory of that specific container, and the granular contextual clues of why it ran out of memory might be permanently lost. Or at best, deeply obfuscated in the massive noise of the platform restart sequence.
Like we said at the beginning, the evidence burns with the ship.
Exactly. By the time your on-call DevOps engineer hears the pager, wakes up, logs into their laptop, and opens the BTP cockpit to figure out what happened, they're looking at a perfectly healthy, newly restarted application. The CPU is low, the memory is stable, and the logs are totally clean. The root cause is completely hidden.
Wow. Okay, now it clicks.
The automation flow we just built in Automation Pilot is not designed to restart the application. Cloud Foundry handles the restart. Our automation flow acts as an automated forensic investigator.
It's securing the crime scene.
The millisecond the app crashes, the ANS motion sensor trips, ALM receives the signal and triggers Automation Pilot. Before the container garbage collection can destroy the evidence, our script executes at machine speed. It instantly grabs the Getsev app state, it grabs those crucial last 20 events, and it pulls those vital 100 log lines in the exact moment of failure.
And dumps it in Jira.
Yes. It securely structures and stores all of that ephemeral forensic evidence in a permanent Jira ticket. When the engineer logs in the next morning, they don't have to guess why the app magically restarted. They have a neatly packaged dossier of evidence waiting for them, enabling immediate, accurate root cause analysis.
That distinction changes everything. We aren't automating the fix. We are automating the forensic data capture before the platform's own self-healing mechanisms destroy the crime scene. That completely shifts how you view automation in a cloud-native environment.
It really does.
So what does this all mean for the big picture?
Well,
We've solved the app crash scenario with forensic capture. How do we take this mindset of continuous optimization and apply it systematically across the entire DevOps lifecycle?
to scale this mindset, the sources point us to a foundational DevOps framework known as the CALMS principle.
CALMS, what does that stand for?
CALMS is an acronym that stands for Culture, Automation, Lean, Measurement, and Sharing. True DevOps optimization requires looking at all four phases of your software delivery lifecycle, which are test, deploy, release, and operate through the lens of those 5 CALMS pillars, constantly looking for ways to reduce manual toil and increase reliability.
Let's make this highly actionable for the listeners. Let's walk through those 4 lifecycle phases and give them specific architectural configurations they can implement to optimize their processes. We'll start with the test phase.
Okay, in the test phase, a major optimization is to automatically reflect updated compliance and security requirements directly in your automated test coverage.
So not just functional testing.
Right. In an enterprise, compliance isn't a one-time audit. It changes continuously. If your central security team mandates a new encryption standard for data in transit, your delivery pipeline shouldn't just rely on developers reading an email and remembering to code it correctly.
Because they won't remember.
Exactly. You need to automate the enforcement. You build static application security testing, or SaaS tools, directly into your CI/CD pipeline. You configure the pipeline to explicitly fail the build and block the transport if the new encryption standard isn't met in the code base. You are shifting the compliance check left, turning a manual security policy into an automated impassable gate in the CI/CD pipeline.
Moving to the deploy phase. What is the tactical move here?
The deploy optimization focuses heavily on automated governance and security as well. Specifically, regularly audit and automatically update permissions for critical target landscapes.
Permission creep is real.
It's a huge problem. As agile teams grow, personnel changes, and projects move fast, permissions tend to creep. A developer is granted emergency access to a production sub-account to debug a critical issue on a Sunday, and that access is never subsequently revoked.
And 6 months later, they still have root access.
Exactly. Your optimization task is to automate the auditing of these role collections. Ensure that your deployment pipelines are strictly using technical service accounts with tightly scoped least privilege access rather than personal user accounts. Furthermore, utilize automated scripts to systematically review and prune human access to target landscapes like production on a schedule basis, flagging any unauthorized role assignments.
Next is the release phase. The sources mention a very specific, powerful architectural technique here, and that is feature toggles. I really want to spend some time here because this fundamentally changes how teams deploy code.
Feature toggles, often called feature flags, are an absolute game changer for the release phase, especially in the incredibly complex hybrid environments we've been discussing with Rotating Banana.
Give me an example of how they use it.
Imagine Rotating Banana is releasing a major new pricing algorithm. This release requires coordinated changes to a public cloud SAP UI5 front-end, a private cloud integration layer using SAP Cloud Integration, and a massive on-premise S/4HANA backend system.
That sounds incredibly stressful to deploy.
It is. Trying to physically deploy and activate all three of those interconnected components at the exact same millisecond to avoid breaking the user experience is almost impossible, requires massive weekend downtime, and is inherently risky.
It's the classic Big Bang deployment. It almost never goes smoothly, and rolling it back is a complete nightmare.
Exactly. Instead, you architect the application to utilize feature toggles. You implement a toggle service, whether that's a third-party tool like LaunchDarkly, or utilizing features within the SAP Cloud SDK. You wrap the new front-end UI code in a simple Boolean logical check.
Okay, true or false?
Right. You deploy the massive on-premise backend changes on a Tuesday afternoon. You deploy the integration layer updates on Wednesday. You deploy the new front-end UI code to the BTP production account on a Thursday. But the entire time, the new feature logic is hidden behind the toggle. It evaluates to false.
So the code is there, but nobody sees it.
The new code is physically present in the live production environment, but it is functionally turned off for the end users. They continue to see the old interface and hit the old logic.
So you are fundamentally decoupling the physical act of deployment from the business act of release.
Precisely. Once all the interdependent components are safely deployed, verified, and resting in the production environment across public, private, and on-premise landscapes, the product manager simply logs into the toggle dashboard and flips the flag to true.
And boom, it's live.
The application router instantly starts directing traffic to the new code paths. The feature goes live instantly. And the best part, if something immediately goes wrong, say the backend starts throwing latency errors under load, you do not have to orchestrate a massive panicked rollback of your MTA transports across 3 environments.
You just flip it back to false.
You simply click the toggle back to false. The system instantly reverts to the old logic. It cleanly handles the release process of highly interdependent changes and drastically lowers the risk profile of releases.
That brings us to the final phase, operate. We've talked extensively about Automation Pilot, but the sources give us 2 more very specific operational optimizations. The first involves the SAP Job Scheduling Service.
Yes. Many modern BTP applications rely heavily on scheduled background jobs. We're talking asynchronous data synchronization, database cleanup tasks, nightly batch processing.
Which can easily get out of hand.
Very easily. If Rotating Banana has 20 different microservices, they might have 50 to 100 different background jobs executing at various intervals. Monitoring all of those individually by checking 50 different logs is a total nightmare. The optimization here is to integrate the SAP Job Scheduling Service directly into the central brain, SAP Cloud ALM.
What does that configuration look like in the platform? Is it complicated?
It is surprisingly straightforward, but it's often overlooked. When a developer is configuring a job within the SAP Job Scheduling Service dashboard, they open the Edit Job Configuration dialog. Within that specific dialog, there are explicit toggles that you can activate to send execution notifications directly to SAP Cloud ALM.
Just a few clicks.
Literally just toggling those configuration options on. You route all the critical telemetry job execution statuses, duration metrics, success rates, and explicit failure alerts directly into the central ALM job and automation monitoring dashboard. You centralize the tracking of all asynchronous execution health, allowing your operators to detect anomalies in background processes from the exact same unified pane of glass they use for monitoring application crashes.
The second optimization for the operate phase mentions a tool that actually sits outside the immediate SAP proprietary ecosystem, but is crucial for modern infrastructure, and that's using the Terraform provider for SAP BTP.
Yes, DevOps optimization isn't just about fixing broken code or monitoring logs. It is about optimizing the operational flow of the DevOps team itself. Think about onboarding.
Okay, spinning up a new team.
Right. When a new Agile team is formed at Rotating Banana to build a new microservice, they need infrastructure. They need a new BTP sub-account created. They need specific entitlements assigned. They need role collections established. And they need backing service instances like a Cloud database or a destination service provisioned.
And if they do that manually,
Doing this manually by clicking through the BTP cockpit takes a significant amount of time and is highly prone to human error or misconfiguration. The architectural mandate here is to adopt infrastructure as code, specifically utilizing the Terraform provider for SAP BTP.
how does that fundamentally change the onboarding process?
Instead of clicking through a UI, the infrastructure architects write declarative configuration files using HashiCorp Configuration Language, or HCL. They write blocks of code that define exactly what a standard secure team subcount looks like using resources like BTP underscore subaccount, BTP underscore directory, and BTP underscore subaccount underscore entitlement.
So the infrastructure is literally code in a repo.
Yes. Once this infrastructure is defined as code, you can create automated self-services. A lead developer fills out a simple internal IT form requesting a new environment. That form triggers a pipeline that executes the Terraform scripts. Terraform automatically authenticates with BTP and spins up the entirely configured subaccount, assigns the entitlements, and creates the role collections in a matter of minutes. It's completely standardized, instantly reproducible, and fully documented in the version-controlled code repository.
Okay, so we have laid out an incredible arsenal of tools today. Automation pilot for forensics, context-sensitive navigation, feature toggles for decoupling releases, centralized job scheduling monitoring, and Terraform for infrastructure as code. But here is the practical reality question.
Okay.
How does a busy team like Rotating Banana actually decide what to automate next? I mean, you can't just pause feature development for 6 months to build all this automation. Where do they focus their limited operational effort?
This is where the culture pillar of Collis becomes the driving force. You have to make the pursuit of automation potential a mandatory systemic part of your team's Agile ceremonies,
Like in sprint planning.
specifically during the sprint retrospective. At the end of every 2-week sprint, the team must not just ask what went well with our feature code. They must explicitly review the operational metrics. They project the SAP Cloud ALM dashboards on the screen, and they review the JIRA tickets that were generated by our automated forensic flows.
Oh, that makes sense. Use the data.
Exactly. They ask a very specific set of questions. What manual remediation tasks did we have to perform this week? Did a senior engineer have to log in and manually restart a stuck queue? Did we have to manually run a database cleanup script because the automated job failed? Did we have to manually provision a user account?
So you systematically analyze the pain points and the manual tools.
You quantify the manual toil, and then you translate that specific toil into new SAP automation pilot commands for the next sprint.
Give me an example.
If you find that an engineer had to manually clear a specific application cache 3 times this sprint to resolve latency issues, your operational goal for the next sprint is clear. Write an automation pilot flow that clears that exact cache automatically the moment the specific latency threshold alert is triggered by ANS. You continuously analyze the reality of manual remediation and incrementally, sprint by sprint, translate it into automated ops.
It's just a never-ending, continuous cycle of identifying toil and writing code to eliminate it.
That is the essence of continuous improvement.
Let's take a breath here and briefly synthesize the massive architectural journey we've just charted. We started at the very beginning with the Agile developer pushing code, exploring the vital mechanics of how the CI/CD pipeline packages that code into a declarative MTA archive and securely hands it off to SAP Cloud Transport Management.
And we learned how configuring virtual ghost nodes allows you to maintain strict, auditable enterprise transport governance without unnecessarily bloating your hybrid cloud footprint.
Right. We then moved up the stack to central orchestration, establishing exactly why SAP Cloud ALM is the strategic, future-proof watchtower. and the critical architectural importance of utilizing a standalone transport management instance to prevent bottlenecks with analytics cloud content.
From that central command, we built out the nervous system. We clearly differentiated the specific responsibilities of the observability triad. Cloud ALM for high-level central monitoring and early warning, cloud logging for granular in-depth root cause analysis, and the alert notification service as the highly configurable event routing engine.
And we emphasize the necessity of configuring context-sensitive navigation to speed up troubleshooting and implementing strict ANS payload filtering rules to combat the culture-killing effects of alert fatigue.
Then we ran through the hands-on lab. We architected a 5-step automated flow using SAP Automation Pilot. But crucially, we didn't use it to just blindly restart a crashed Cloud Foundry app.
No, we used it to act as an automated forensic investigator, capturing the ephemeral platform state, the lifecycle events, and the volatile console logs the millisecond the crash occurs, securely storing them in a Jira ticket before the platform's self-healing mechanisms destroy the evidence.
Finally, we expanded that automation mindset across the entire DevOps lifecycle using the CalMS framework, automating compliance checks in the pipeline, implementing feature toggles for safe hybrid releases, centralizing asynchronous job scheduling monitoring, and utilizing Terraform to turn infrastructure provisioning into executable code.
It is a highly comprehensive, deeply integrated architecture for transforming a reactive stress development team into a proactive, highly automated operational powerhouse.
It's a journey, but it's incredibly rewarding when you get there.
But before we wrap up this deep dive, I want to leave you with a final, somewhat provocative thought to chew on. It builds on the philosophy we just discussed, particularly the idea mentioned in the sources that in this never-ending DevOps journey, the way is the goal.
It is a profound way to view continuous operational optimization.
It is. But let's critically examine the dark side of that automation for a second. We just spent an hour architecting a brilliant, highly efficient system where SAP Automation Pilot instantly captures forensics or even automatically remediates known issues.
Right, self-healing systems.
If a database cache fills up, an automated script clears it. If a legacy service hangs, a script restarts it. Everything looks beautifully green on the central SAP Cloud ALM dashboard.
This is what you want, right?
Well, here is the architectural challenge for you to take back to your team tomorrow. If SAP Automation Pilot is successfully and silently automating all of your remediation tasks in the background at machine speed, who is monitoring the automation?
Oh, that's a good question.
How do you ensure that your brilliant, highly efficient automated remediation flows aren't actually just silently hiding deeply rooted fundamental architectural flaws in your underlying application code?
The immense danger of the perfectly operating duct tape system.
Exactly. You could be staring at an ALM dashboard that proudly reports your system is operating perfectly with 100% uptime, while in reality, the core business application is suffering from massive memory leaks and crashing 50 times a day. And your automation engine is just frantically applying digital duct tape, restarting it over and over again before the end users notice the latency.
You're just masking the symptoms.
Are you using your automation platform to actually fix your fundamental engineering problems, or have you just architected an incredibly efficient machine for hiding them? Go look at your Automation Pilot execution logs tomorrow and ask yourself a hard question. What is my automation actually compensating for?
That's a scary thought to end on, but a necessary one.
Until next time, keep digging deeper.